Hello everybody, welcome back to the stream. The message is supposed to say going live any moment, but it's too small. I forgot to make this wider. So it is going live whatever you want it to be. Thanks for the bits, Kartoffelpuffer overflow. Okay, alright. So today, as you can see from the stream title, I don't plan to continue working on the 8-bit computer. This will be a thing, I guess, for tomorrow or so. Today I want to kind of have like a post-CTF chat. So the Google CTF happened over the weekend. I played again, which felt good. Haven't played CTF in a while. And so yeah, I just want to take you along. Basically, this is what I would do now if I were alone. I would just look up write-ups, try to find write-ups, revisit some challenges, and maybe we can even like do this kind of together. Like maybe we, like you can help me maybe understand something if you have solved something that that I struggled with, or maybe I can tell you a little bit about how I solved something. However. Okay, yeah, so that's the goal. So, first of all, let me switch the screen. Alright, so the Google CTF happened over the weekend. The challenges are still up. I don't know how long these servers will stay available. So if you want to try it out yourself, maybe do that soon. However, Google is also generally pretty good at archiving those challenges. They even publish source code or instructions how to host those things as well on their GitHub at some point. So there's also an option for that. Also, they reward, I believe they reward write-ups, or at least they want certain write-ups for challenges because it was like a qualifier for the finals. So I'm sure there will be some really good write-ups coming out in this coming week. Maybe today, the first day, looking for write-ups is maybe a bit early already, but whatever. You know, it's like we take what we take what we can get. Thanks for the sub, Uber 1337 mate. Okay, so the scoreboard. Okay, so maybe first generally a little bit about the CTF. Volume is. Oh, sorry, I had my microphone turned the other way. Is it now better with the volume? Yeah. Anyway. Again, congratulations to those top teams, Paste, Rank, Sector, P4, but even here the others. Greg Rocket was really surprising. Spam and Hex. It's incredible what these teams are doing. We got 15th place. I'm playing with Alice, which is really good, but I don't think that this is like my success here. So we solved quite a few challenges. I solved one challenge, okay? I solved one and I helped a bit with another, and all the other challenges I looked at, we never solved, or got failed and stuck at, okay? So results like this are often team efforts. Multiple peoples have been working on these challenges. So, you know, okay, so don't look at this and think that this was somehow my success. You solved 2? Well, that's the double amount of challenges I solved. Pretty impressive. I assume you tackled some of the hardware challenges. Okay, so what was the challenge I solved? Maybe really quick. I like I said, I want to look at challenges that I didn't solve, that I tried out, and want to kind of try to understand what the solution was. So the one challenge I did solve was mind test. That was really fun. I didn't prepare anything. Maybe somebody did like a screenshot. I believe I saw some screenshots on Twitter. Okay, so maybe this is not the best. Oh yeah, there we go. KEG or Q3K or whatever. uploaded some images. So it was like Mindtest is a Minecraft clone, and on there was a huge circuit network implemented. If you have watched my Pwn Adventure video series, it looks kind of similar to the Blocky challenge, just way more extreme, more input. It was like 40 something bits, I think, as input, and then at the end a single output, and you had to make this true. Keck has already released a write-up about it. He has a pretty clever solution. Just very briefly how I solved it. Basically, I parsed the SQL map file, extracted all the different blocks, reconstructed the basically put that into a huge structure, and then basically I walked backwards from the end, all the paths. So at the end there's like obviously a single output node goes into the first gate, and then I'm following that was an, I don't know, an AND gate or something, and then I'm following the two inputs paths to the next gates until I reach the inputs. And along the way I construct a Z3 Boolean formula, and then at the end I can just solve that. That then went pretty fast. But parsing that SQL block and node format, that took me the longest. That was really what killed time, because it's a bit weird. There's good documentation. Mindtest is open source, but especially with I had problems first of all, they call things blocks, but blocks are these 16 by 16 nodes. So I thought I was constantly handling blocks were single blocks, but no, this was a block was a chunk and nodes were blocks. So that kind of cost me time, and then I had troubles figuring out how I can tell the orientation of blocks, because that is important for the connections to be able to follow the graph. So I had a couple of hurdles. In the end, I did solve it, however. I checked again, if you're curious about the time, how long it took me. I downloaded the Mindtest folder at 3 a.m. At night. At 3 a.m. and I solved it and handed in the flag at 4 p.m. Okay? So I worked basically 13 hours on this. I'm right now on a completely screwed up sleep schedule. I woke up at 7 p.m. today. Now it's 10 p.m. So yeah. So I worked from 3 a.m. to 4 p.m. for that single challenge, okay? I don't remember. I probably also procrastinated a bit, maybe looked at some other challenges in between, tried to help out with other challenges. But yeah, this is from download to handing in the flag. Yeah, so I'm not the fastest, clearly not. Okay, so wait, chat, sorry. Are these programming challenges? These are, in that case, that particular challenge, the Mindtest was more of a programming challenge, because you needed to parse that format. But then in the end, you also had to understand how to solve a huge logic formula or Boolean formula. You solved secure EEPROM and poly of Legram, right? Oh, nice, cool. Did we? Well, I didn't work on these, at least. I didn't solve a pwnable. 13 hours for Minecraft. What challenges will you look at? Okay. I tell you about the challenge I want to look at in a second. Just really quickly, I solved it with Z3, the Mindtest logic formula. I really love how Q3K or Kick solved it. Basically, he created a Verilog netlist, and then let basically these Verilog FPGA, or this whole tool set that is exists for hardware chip design, let that solve these connections. And I think this is I love that solution, because you use tools that were created for a certain kind of product or industry, for chip design, but it includes solvers to help you improve your connections on your PCB boards or your hardware, whatever. And so to be able then to use such a tool, to understand the capabilities of such a tool, and then you use it to solve such a CTF challenge, I think this is really, really awesome. Z3, on the other hand, is purposely kind of made to solve these kind of equations. So you use a tool that was specifically made in a programmatic way to easily solve this, but to really use here a Verilog netlist optimizer, or I'm not quite sure what you use there, I think is really cool. Will you make a video series about this? I mentioned it really quick right now in case questions come up later. Again, I don't want to repeat myself. I will not promise to make any videos. I explained this already last stream. Once I promise to make videos, there are certain expectations and pressures. And once you announce that, and there's like this psychological effect that I strongly feel, if I announce that I make certain videos, then you get the dopamine reward already, and then you lack the motivation and the motivation to actually finish it. So I rather have you not expect anything, and then if I don't do anything, fine, because you didn't expect anything, and if I do it, then I can release it and get the psychological reward for releasing a video. So absolutely no promises, but what you get today is a little bit the post CTF talk. So yeah, so this is the only challenge that I solved. Now, in the end, he did SAT solving using the formula verification tool. So it's similar to your solution. Yeah, I understand that it's like the same, that it's also a SAT solving tool, but that tool is just part of something else, right? It's like the Verilog hardware design creation tool set has a different, it has the same purpose essentially to optimizing connections, of course, but I don't know, it wasn't, okay, wait, I don't know. Okay, if we talk about it like that, then yeah, I guess it's not as crazy, because yes, these were also purposely built to optimize, the same as Z3 was built to optimize and solve equations. So I guess they are the same tool. I don't know, I just find it awesome to turn it into a Verilog into a netlist and let this tool set then solve it, rather than, I don't know, Z3. I don't know, I don't know how to explain. I feel like there's something cooler about this. So there's a question, did you have a look at the Braille challenge? Yes, this was one of the challenges, for example, that I worked on and spent quite some time on as well. But somebody else on the team had the winning, or two different people on our team both had different steps. I kind of started with that. I think, yeah, that was the challenge I started with, I think, on Friday when it started. And did a lot about the Braille, tried to different injections with Braille characters and special characters, but nothing led anywhere. I was enumerating and brute forcing different characters, seeing if anything would kind of trip up the database or whatever, the application that is handling the Braille. But basically I couldn't find anything. And then some other team member realized the XML input, that there's a middleware that handles XML, and then I'm not sure if this was the same person or somebody else, then found the XML entity attack, that a particular one that kind of worked on there. Yeah, and I think almost everybody who solved it kind of copy and pasted the solution from port swig or block. It was basically in the end just a copy and paste. Did you try the paste static challenge? Yes, this is another challenge that I spent a lot of time on. And this is one of the challenges I want to have a look at now, because it had no solves during the CTF. Somebody got really far, and we kind of chatted in IRC a little bit about the underlying bugs, or what is kind of abused there. And I had some of the ideas, but I was lacking some kind of information. So this is something that I'm not sure if I want to solve, if I will be able to solve this basically now on stream. I doubt so, but I kind of want to, there are a few things that I've heard about that I kind of want to explore and try out locally, just to see how that will work in theory without pulling off the whole chain, because it's like a little bit of a chain of things that you need to combine to fully solve this. The numbers were just the Braille characters on the numpad. Yeah, I know how. Yeah. I stopped after translating the logo. Yeah, in the end it was an XML XXE or X don't know, whatever challenge. We communicated over the internet. We just hung out in a voice channel a lot of the time. IRC is used for the CTFs. Most of the CTFs, like the Google CTF, have an official IRC channel where you can contact and talk to the organizers and admins if there are technical problems. And after the CTF, the players usually just meet there and exchange solutions, ask questions. So being in that IRC channel is a good thing. You also get notified if something breaks or if a challenge has problems. So the IRC is generally a good place to be during this CTF. A lot of people still use IRC. By the way, we know that fact now. You are actually using IRC right now. Twitch chat has IRC as its backend. Just let you know, there is an IRC server and you can just join the live overflow channel on that IRC server if you directly connect to the Twitch IRC network. And some people, that's how you write Twitch bots. I guess, yeah. This chat is basically IRC. Yep. That's also why there are people that hang out all the time. So, for example, I believe right now, if you look in the people that are in the chat right now, there are just always, even if when I'm offline, people are hanging out. Those are probably people who have just joined the IRC channel and just idle around. This is just a graphical interface as a front end for the IRC server. Yeah. Anyway, okay, so yeah. So paste static, BNB, that was the Braille challenge. Those are the two I spent a lot of time on. The mine test challenge is obviously something I spent 13 hours on. So that obviously also cost a lot of time. And I believe I didn't look at any other challenge besides this. I also spent some time on the chit challenge. I was fuzzing it with AFL, but I didn't properly do the input sanitation, and so the fuzzing crashes weren't necessarily usable for the for the actual channel service. After I tried to get the Java thing to compile and installing the dependencies to be able to compile the Java front end thingy that they were also sharing in the code, I gave up on that. So I spent maybe overall probably also like 2 hours or so just like reading the code, setting up the fuzzing, and then realizing that the input validation is a bit of a problem. And so I didn't really get far with that, and I'm curious what in the end was the main bug, or the bugs like maybe even that could be abused there. Chit was such a pain. I managed to exploit it, but the Java sanity check blocked the exploit. Yeah, so there were a lot of crashes. You could pretty easily crash the JIT, but the input validation is basically the that you have to basically write pretty valid code. So that's what I mean. I could have implemented that validation in C as a fuzzing harness around it for fuzzing it, but I was kind of dreading that. I did only basic checks to make sure no special characters, so only ASCII. That's a pretty basic, just a loop around your input to make sure that you have just ASCII bytes, the uppercase parentheses. So this was already helping to throw away a lot of crashes that are related to different kinds of characters. But then still, you don't have balanced parentheses or similar things like that. And so the fuzzing results were all invalid, basically inputs. So yeah, if I would have spent more time on this is what I, for example, would have done. I would have implemented a better sanity check for the fuzzing harness, or maybe, and then while that is running, and I'm not sure if that would have been a good path. Maybe it would have been better to just manually review the cheat code to figure out a way how you can do more stuff. The only thing I've kind of found out I guess we should open this maybe on stream while when I'm talking about it. You didn't play it. So, oh my god, I clicked on this. So there was this Java file that was just basically doing a sanity check around the data. So the challenge is called JIT, but basically you just pass in, there's an example code. So this is how the code looked like that you could pass in. You have 2 registers and you can do certain calculations and read, and then you get the result out. Yeah, and so I modified this program to read from a file, and then I used AFL to fuzz it again, but the input checks were not fine. So that's kind of what I mean. It's called JIT, means just-in-time compiler. It's not really a just-in-time I guess it is just-in-time compiler. So you have these text instructions, and they then get compiled. They're here hard-coded. Their equivalents in assembly. So move instructions would be encoded with an actual, this is the byte for a move instruction. So it was really creating the assembly instructions and putting that in a writable, executable memory area to then execute. And you needed to somehow break out of that, get your own code in there, get your own shellcode in there, maybe, or do some memory corruption with that. Maybe you can read or write out of this JIT's allocated memory space. Somehow you needed to exploit this. The only thing I found basically was that there was a value in RAX. It was like an address of the address of maybe the JIT section or so. So some address was in RAX. So if you were just immediately returning, you could leak like an address. That's the only thing basically. Or you could use A and it contains the address already. So maybe that would have been part of the solution. But that's the only bug, so to say, I found. And like I said, the fuzzing didn't lead anywhere. Anyway, so this was the other challenge I looked at. I spent a little bit of time on what was it? That's MISC. Was with the was it web? No. Wait, I'm confused. Wait, what was the name of it again? The one with the where you have to turn off the TV. Was it this? No. Probably wasn't MISC. I'm blind. It was on the hardware. Hardware flag ROM. Oh yeah, remote control. That was the challenge. So in the remote control challenge, my stupid face is in the way. And you can't scroll further down. It kind of works, I guess, with the description. You have like the idea is that you have an IoT hub, like a central device, and that device can communicate with a clock that is also hanging in that apartment. And there's a TV that is supposedly on. And you have the client tool that is accessing this IoT hub's web API. And you can like ping the clock and you can interact with the clock. And I didn't fully look into it because other people worked on it. I just really briefly looked at it maybe for like, 15 minutes or so. And so somehow the idea would be that you can, that you use this IoT hub, which is communicating with the clock, to use its like infrared LED that it has to communicate, but send the actual, like exploit it so that it sends the TV turning off signal. And so the approach we had was that there are these TV be gone that just implement a lot of different TVs turning off infrared signals, but we just couldn't get it to work. People were trying it, but it just didn't work. We don't really know what the problem was. I only solved the mind test challenge and failed with a couple of others. One challenge I helped with, we also solved, but I wasn't the main contributor to that, and the other challenges I kind of just failed. Anyway, okay, so I would say the first challenge I want to look at is the paste static challenge. That was just kind of insane. There was a little bit of a write-up that I didn't, it was just a source code, didn't really understand it, so I want to explore that a bit more. Let's see, yeah, here, this is the write-up by Katie. So let's see a little bit also here what other people were writing about it. Okay. Paste static was one of the most fantastic challenges in 2019. I was aware that there's no origin check at handling messages event in window. Config can be removed by XSS filter, but couldn't come up with any more ideas. Yeah, I can also tell you how far, kind of like how far I got with it. Yeah, no, these are super old challenges. Okay, I guess there wasn't much discussion about it on Twitter. Oh, no, the hardware challenges were all kind of like, you didn't need hardware. They were different. You can go on the website and download the challenge files. You will see that you don't need hardware. Okay, so Katie listed here some files. Let me show you a little bit what I figured out about this challenge. So when you create here a file, does it still work? Okay, it still works. It's great. So you create the file, you get this file now, it has like a view URL, and if you look at how this is implemented, you see that this is actually loaded in an iframe. So there's a sandbox iframe where the content of this file is loaded. And the sandbox iframe has the sandbox attribute allow same origin. Otherwise, it's sandbox, which means you are not allowed to execute any JavaScript inside of it. So then if you look at the source, code of this challenge, one other thing is if you load the view page, let's go back. So there's a bit of JavaScript going on. So if you load the view page, you can see that this iframe is not there. So the iframe is not there. The iframe is dynamically created by the app. So this is the JavaScript code. So there's this viewer class, and it kind of starts down here. Either you are on the this is unfortunate. Wait, do I have Sublime on here? Yeah, I do have Sublime. Why do you use Chrome? Why not to use Chrome? I'm an idiot. I need to copy this. Okay. To be honest, I don't care about the privacy. I have my mail at Google. My whole company is at Google. Okay, so also this challenge, so the web challenge like this might be also browser related. However, I mean, should have then also worked, I guess, on Chromium. Who knows? Like this was so I looked at this challenge pretty early off the CTF, right? So I didn't know how hard this challenge would be, and I made some pretty good progress that I will show you now. But ultimately, I wasn't like far enough to even solve it. I got stuck at some point. And then throughout the CTF, I realized nobody was solving it, and then realized, oh, this is a pretty hard challenge. So when it's such a hard challenge, it might be that it's a very weird browser quirk, something that just happens on that specific Chrome version or that specific Safari version. So browsers sometimes have weird quirks, and only people that really research that topic might be able to solve it, because they happen to have found these same quirks as well. So that's kind of like an assumption that you can have if you see such a client-side browser XSS or whatever challenge. When when there are no solves, it must be something kind of obscure. It wasn't that obscure, to be honest, but I feel like I got some good. I was on a good track, but clearly I wasn't like enough to solve it in any way. Hi, Cold Fusion. No 8-bit today. We are reviewing challenges from the CTF that happened on the weekend. Okay, so yeah, so either you're on the create view or the view. So the view is the view where this iframe is created. So we can look at that function here, and you can see it gets some. There's a content ID tag. It gets the lines from there. It gets the data language also stored in there. Then it gets the viewer element. And then there's already like a differentiation between markdown and not markdown. And then also this viewer is then created, this viewer class is created. And then the rest is pretty, so it registers here a do report, function unimportant, captcha unimportant, and then it initializes the viewer, and then also it renders it renders the based on the language, it puts in the content and false. So it calls render on the viewer as well. And then populate recent is also unimportant, is for recent views. And so if we look at the viewer class, when it's creating, it gets this view container in there, and there you can see it creates the element. It loads /sandbox as the as a source domain path. It sets the sandbox attribute, and then it adds some like event listeners for loaded, and then it appends the sandbox iframe to the container, and then it also registers an event listener for messages. So messages can be used for iframes to communicate with each other, which is kind of an important point here. Then we know it calls init. On init, it then gets this sandbox iframe. Now it looks into the config, and yeah, it gets this config, and then it does like a loading. It loads these scripts defined in that config. So you can see it like loops through the dependencies, and then it calls load script on this dependency. When that is done, it goes through all the preloads, and also does load plugin on all the config preload plugins that are being done. Now, if we look at load script and load plugin, we see that load plugin calls load plugin and load script as well. There's just some housekeeping of the data. And then load script is very interesting because it gets the integrity. It fetches. So this is downloading that resource, that URL. I guess I should show you how that. So here you can see the config defined. It's just like a JSON or an object, I guess, JavaScript object with dependencies and plugins or something. Yeah, plugins here. And there's a integrity check that's just unimportant. And the URL. So it downloads here that script. And then when it gets that script, it will call init script on the content window with script. And init script then calls eval inside of that sandbox window. Okay? So this is kind of important to understand. Now, of course, during the CTF, I was also looking at different kind of things. So, for example, could there be XSS in the recently added ones and all these things? What is otherwise so important here? Yeah. Then I guess it's still important also this event listener. So init listener is being called when the sandbox here, when the viewer is created, and it adds inside of the sandbox window, so inside of the iframe, it also adds an event listener for message. And here it checks the origin, and then it checks what kind of message this was. Was it a render message or was it a scroll message? And in the render message, then it just removes here things from the viewport. And here's again a check for markdown. So it checks if the language is markdown. If that's the case, then it will do inner HTML on marked of that data. And I found out that marked is a function defined by the markdown renderer that this website is using. So they render the markdown as like HTML, you know, just not the raw text, but they render it. And so they marked it and they turn the sanitizer on. So it should be safe HTML that is coming out there, and then it's assigning inner HTML. If that's not the case, it just creates a code element and puts the raw data in there, and it's all fine. And then it does a highlighting of that code. I actually have a Sublime license, just not on this machine. It's on, like, I don't know, I have so many different computers. Okay, so here's the thing that I found out. I found that out through a bit of testing. So this is something I did. So we can test this really quick. Let's create a new markdown file, mark1, and then we can just like test this. We can do like a header, header test. We can also do like a link. Okay, so now we have some markdown, and then we can submit. So here's our text, and you can see it's not rendered. Fail. Why is it not rendered? I guess it doesn't render headers. It's fine. It rendered the link here. So if you look at the HTML it created, you can see that it created like an. I guess that maybe there needed a space between the whatever. Doesn't matter. You can see that it rendered the markdown for a link as an anchor tag here. Need a space between. Yeah, okay, fine. So you can see that that renders this. Oh, by the way, the goal of this challenge was kind of an XSS or stealing channel. You can do this DMCA here, and DMCA is reporting that data that pastes there now to the challenge administrators, the support people, and they will look at this. So this is also something that I explored. You know, you see the submit URL, you can submit other URLs, and then you see like the pingback, you see a browser accessing the URL that you are submitted for the DMCA takedown. So basically the idea is you create a malicious DMCA request, and the support person or the administrators clicking on it, and then they execute your exploit of the XSS and you steal some internal data. I'm not exactly sure where the flag is. I assume the flag is stored in a secret paste that would be listed in the recent paste that you can see when you just go on the page. So somehow if you have XSS, you don't see this right now because like in the bottom right, or bottom left, I mean. So recently viewed, I assume that the flag would show up here if you were the admin. And so if you XSS the admin, you can then look at the site and extract the data and send it back to you. So I assume that's the goal, but I'm not sure. But so that's kind of the goal. There we get it. So we are looking for a client-side attack. It's in cookies. No, this actually doesn't use cookies. This uses, where is it? Is an application. This actually uses the local storage. So this just stores whatever you created in the local storage. So there's a recent, I think, sorry, you're right, sorry. I forgot. Right, the flag was in the cookies. Sorry, I totally forgot. There's a flag cookie that is set for us. It's a temp flag ABC123, which is a hint that the solution flag is also in the cookie. We need to steal the cookie of the person looking at the site. I totally forgot. Thanks for the reminder. No, actually, you need the XSS protection in Chrome to make this exploitable. That's one cool thing about this challenge. You actually need to abuse the auditor in the case here. So that will make fun. Like I said, there are multiple stages that you need to combine to make this exploitable. That's why it's so hard. And like I said, I doubt that we will solve this now. It's a bit too much of a setup, but there are some crucial things that I didn't know about that I kind of want to now experiment with. Okay, so now I show you also the one thing that I kind of found out and I thought I was on a good track, and that is an XSS. So there is filtering happening. So if you do like a script tag in Markdown, like just something basic like this, then and you submit that, and then you look at this, then the script tags are gone. So they are just gone. They are not there anymore. And I found out this, if you have a script tag at the front, then you do a second tag, and then you do a thing in the middle there, and you basically do also one in the middle here. And when you now submit it, so here's kind of the text. If you now submit that, then obviously this doesn't do anything because sandbox, but let me show you. Hopefully I did this correct now. Body, come on. Viewport. There we go. I screwed up a bit the format. Yeah, so you can see there's an script alert now. Wait, script alert in HTML doesn't work anyway. Let me do, and this is basically about any tag. So you can do like an image tag, fake an image tag like this, and then src equals to x on error equals to alert 1. Some other attribute, and then we can throw this here away. So I think this should work. So you see here the broken image, and you don't see the alert, but like I said, that's sandbox issues. I can explain in a second. So you see blocked script execution because documents frame is sandboxed. It doesn't have the allow scripts thing, but you can see here the image is now in there with an on error. So this is a bypass of the sanitizer. If you, we can also go here in the sources, and we go here in static in the app.js, and we look for, so this is the sanitizer here. So we can set like a breakpoint here. Let's reload the page. So so there's a breakpoint now set here. So now, so yeah, you can barely see the console down there. There we go. Okay, so God damn it. So EVT is the event that is coming in. Text, it's like an on listen event. It's this renderer message. It's like it's listening on you should render this now. So this is executed inside of the context of the iframe. So you see this is our data that we passed in, script with the broken thing, and it has the sanitizer turned on, and the sanitizer is just replacing it with just stripping stuff with empty. Now we can execute that, and now the inner HTML of this viewport, I guess, crap. We can also execute it like this. This is how this is basically how I tested it. Wait, I'll show you how I tested this. So marked is the function. So you can do marked of a string, of the string, for example, and then you need the options here. There we go. So now you can just, like, this is how I played around. This is how I found the bypass. I was starting out with just like image tag. So see here's basically how I discovered this. Image source X alert on error alert 1. Okay, so we start this, right? This would be an XSS vector. Put this all on one line here. Okay, so you see it's completely stripped. Then I tried what happens. So I was kind of inspired by the Google XSS, you know, maybe, I don't know how the sanitizer worked. I didn't look in the source code at all. So I thought, it's in a sandbox iframe and things like this. Let's see what happens with no script. Nothing happens. Then I thought, okay, when it's stripping, if it's server-side stripping, then something like this often works. Because it's not recursively stripping oftentimes. So if it strips away the script tag, then this kind of works. So it broke the image tag now, but it encoded the lower than sign here, LT. So I thought, that's weird. And then for whatever reason, I placed another script tag in front of it, and suddenly it turned into a full image tag. And so that's how I found the bypass, basically. Okay, so now we have XSS execution theoretically in the sandbox iframe. We found a bypass of the sanitizer of this library. But it turns out, I believe this is actually completely not important for the solution. I believe the solution, so the write-up by Katie was also not complete. So this solution only worked locally. It didn't work remotely. That's why this person didn't solve it during the CTF. It has 0 solves during the CTF. So I'm not quite sure why it's not a full solution, but like I said, I'm not sure if I would solve it now. Anyway, it's more about exploring some of the concepts I didn't think about or realize. So yeah, so I thought I was on a good path. This is kind of how far I got. And then I thought about if you can somehow, you know, make that sandboxed iframe still be able to execute that. But the problem is it's not a reflective XSS, right? It's a DOM XSS. It only happens because the view page is embedding the sandbox iframe, and then it sends a message to render that in the iframe. And so, yeah, that just didn't work. Okay, so now we come to the part that I'm interested in, like what kind of is the solution. So now let's look a little bit in the files that this person has uploaded, because there are some really weird, interesting things here. Did you get the version number of the remote admin? I'm sure the kind of user agent somehow included that, but yeah, not really. It's definitely not a browser exploit. I mean, maybe you could have solved it that way, but this was another thing, you know, maybe they were trolling and they were actually wanting you to exploit a browser. We had these kind of challenges before, or people solved it that way. Anyway, so if we look at this person's exploit HTML script, we see that first of all, it iframes. So here's an iframe. Okay, so you don't see it, it's behind my face, but this is an iframe and this is the URL of the iframe. And the URL of the iframe is a view URL. But the interesting part is after the view URL. So here the view ends, right? This is the whole view URL to the left of it. And then there's a fake XSS parameter containing the config variable. So if we just copy and paste this here. Oh wait, we can do it ourselves. So basically what the person has done. So this is the website, right? Basically the person has taken this config JavaScript, this variable in the JavaScript, added a fake parameter. That parameter does not exist, right? It's like anything, ISD, whatever, equal to this. And see now how it turns red. That's because the XSS auditor, the thing that is supposed to protect you from XSS, is, in this case, configured to just block the malicious script. The site still is, it doesn't block the whole website and stops you from going there. The only thing it does is it blocks that particular config script, okay? So now there is no config available anymore. Yeah, I only solved the mind test challenge. Okay, so this is a crucial step that I actually a little bit thought about this. So as we know from the JavaScript, it uses the config in the init to loop over the dependencies, and then in the end it ends in an eval of that script inside of the sandbox. So if we could somehow change the config variable to contain a malicious script from us, then that malicious script from us would then be injected into the sandbox and then evaled in there, which then would have access to the cookie, and our script could then steal the cookie. So that was one idea I had. And there is this idea of DOM clobbering, but there wasn't a way how I saw how to execute this. I also didn't think of disabling the config itself. I was just thinking of DOM clobbering. So what's DOM clobbering? DOM clobbering is an idea of that. So when you have an input tag, for example, with like IDs like this, or like here. Okay, so here, there are two links. One has an ID X and a name Y, and then suddenly there are JavaScript variables with the name X and Y. So because this href has an ID X, you can access this just with the variable X. And so you never created that variable X. Just because you included that in the HTML, suddenly there is this variable in JavaScript available. And you can use this to kind of set variables in JavaScript that shouldn't be set, or you can override sometimes stuff. So this idea of that the HTML tags with certain attributes clobber or poison or influence the JavaScript variable space is, one of the attack ideas. And so I thought about this, obviously. Like I saw that in the code, it would take the config to take those URLs and execute these. So if we could somehow change the config, we could execute our own stuff. And how do you influence a variable in JavaScript? Either you have a full XSS, then you could just, by that I mean just some JavaScript context where you can set a variable, for example. This is a way how you could maybe change that. But obviously that would already be very powerful. And the other option would be that maybe we find an injection that doesn't allow us to inject JavaScript, but it allows us to inject other HTML tags, and then we could use those properties to still influence the script execution by giving it a name and an ID. Even though we don't have a full JavaScript XSS, we still influence the script execution. That kind of was like an idea. I wrote that down in our CTF notes as maybe clobber config or something. Wait, I can read you exactly what I wrote down. I'm really proud of that, as you can tell. So I wrote down, other attack idea could be clobbering config somehow. This could trigger an unsafe eval inside of the sandbox iframe to leak the cookie. But we would, and I added, but we would need at least an HTML tag injection in the view page here. So that was kind of an idea I wrote down. It seems to have been part of this, but one crucial step was that you first need to disable that variable. You need to make the browser delete that config variable, because so when we loaded this page with the fake, so the XSS auditor was triggered and we inspect the console, we see the error message. So the XSS auditor refused to execute a script. It thought that our injection with the config was injecting those variables. It obviously didn't, but it caused the browser to strip away that config variable now. And now you can see that the script fails because it can't find config anymore. Config is not defined. Config doesn't exist now. It doesn't exist anymore. And so now the idea is, if you are somehow able to now get like a tag in there with this config variable, then suddenly this variable would exist. Yeah. Yeah, it wasn't solved. There's only a solution that seemed to have worked locally but didn't work remotely, so it kind of contains a lot of the solutions. But wouldn't it still be blocked because of the script tag? We are not. There's no script tag right now. Okay, so I know this is like really it's a mind-bending challenge. There are a lot of different moving parts that are kind of influencing each other, and the whole exploit at the end, the whole attack, will be a chain of multiple weird browser behaviors, okay? So I have a hard time wrapping my head around this. I'm not even sure I can. Like I said, I'm not sure if I could even solve this now with those hints. But there are a few browser behaviors that I want to explore now that are part of the solution. And one part was here to abuse the XSS auditor to disable the config variable. So this is one puzzle piece that we have now, that we are able to abuse the XSS auditor to disable or to remove the config variable. So now the site is broken, doesn't have a config variable. Just FYI, this behavior of the browser is due to the XSS auditor header. If we look at the response headers, I'm not sure if is it. I believe it's because it's a default now. So you can see there's no XSS response header on here right now. So this is the whole dilemma we are in. This XSS auditor is a curse. So either it blocks your website entirely. If you watched my videos about the XS leak, it was a challenge at the C3 CTF. So either you have the browser blocks completely the site, then it can be abused for an attack called cross-site search leaking, which is bad. There was a CTF challenge I made a video about, so you can watch that if you don't know what it is. Funnily, that challenge was created by a Google employee. So like Googlers know that this exists, right? They are in a dilemma here with how should their browser behave. So we have cases where blocking entire sites with the XSS auditor can be abused as an attack. So now the question is, what should the default be? Let's just strip the scripts. But this is also a known attack, because stripping certain scripts allows you to influence how the site behaves and opens up attacks like on this CTF challenge. So this CTF challenge is an example for how stripping away certain parts of scripts can influence the web page and possibly lead to open up attacks. So now we have both options somehow lead to an attack. And completely having no XSS auditor is also, I guess, a problem. Then you have just regular XSS, I guess, in a way, you know. Anyway. So this auditor trick is required because DOM clobbering won't override an existing variable. I believe so. So here's the thing, like, where I have somewhat like heard about these things, but I'm also not sure. This is like what I'm here for right now. I kind of want to explore these and test these things again to build that experience and that knowledge about how this exactly behaves. Because these kind of precise questions that you were asking, Alex, are exactly the things that you need to know if you want to solve a challenge like this, right? I just knew that there's clobbering, but I didn't know exactly the context of it. So now is a good time to explore this, basically. That's the idea. Okay, so let's look a bit more at this script here. Now, here's another part that I'm not quite understanding. So I also don't know right now how you get the clobbering into the view page, right? But the script above here is supposed to do that. I'm really not quite sure. I still don't know. Maybe I need to draw this open, because there are multiple pages now involved with iframing each other. It's and sending messages around. It's like crazy. So this person here, this exploit script has an iframe, and it iframes the view page. And now it goes into that iframe, into the content window, which is a different domain. So this is cross origin, but you can still access the window of the cross origin. And I didn't know that you can access the frames and change the location of that frame. I didn't know about this, so this is something I want to test out. Is this not, is it not in violation? Why is this allowed, or is this just allowed? Is there some special case where it's only allowed, or is just the case? Like you can access you can iframe a site and you can access the frames that this frame included, but you are not allowed to access the content. I know that the location of iframes in Windows, this is a property that you can write to. So you can force a redirect of a window that is not on your origin. You can't access the content, but you can redirect it. So my assumption is, and that I didn't know, that you can follow this chain of windows and frames down to whatever and then change the location of that frame. So, and apparently that you can do. But and then you change the location of that frame. And then when that is loaded, now it changes the name of the frame. And this is where the clobbering, I guess, happens, because here's now the name config assigned. And my assumption is that you are allowed to change the name of the frame because the name is your domain from which this exploit is loaded. So at the top, you have your site that iframes the view. That view has another iframe. You redirect that bottom iframe to your origin. Now both the top domain, then there's the middle view, and the bottom domain is your origin, and now you can change the iframe name of that your origin. That's at least how I imagine it right now. We need to verify if that thought is true. And now you can change the name, which then causes a DOM clobbering in the middle page of the view, which changes then the config variable. That's kind of how I imagine it right now, but not quite sure. So we need to review that. It's like mind bending. We might need a paper to draw that to visualize this. It's like crazy. That's why it works, I believe. Okay, I'm really curious because I wasn't quite aware of these kind of details. So I'm really looking forward to kind of test this out. And then there are a few other scripts that I don't understand in here. So this is one thing that we need to do. The exploit pi is just a server that serves the data. And then there's this inner HTML here. Wait, what does he load again? He loads, so the bottom iframe is loaded toginner now. And ginner does what? It just iframes viewer again. Like, wait, if he iframes viewer. Okay, yeah, I have no clue what's going on. Okay, so I don't know why it does that. And then there's this helper markdown, which is an image tag with this JavaScript, which I don't know what this is. I believe that's just to make sure that this script exists already, that it doesn't have to be downloaded first, basically to not wait for it, but that the browser already has it in its cache and can just serve it immediately and execute it. That's the only reason why I believe this is used, but really not sure. And I believe the inner iframe, the iframe that this ginner HTML is loading, I believe would then be that markdown to make sure that this script is loaded. But I'm not quite sure why. And then, yeah, we have that script here, and that script here, that is then the actual leak. So I'm not quite sure how this, this JavaScript might be then, wait, paste exploit. Oh yeah, wait, I think I got it now. That should be part of the config now, right? So if we look at the config, that it's config frame name. Yeah, I'm not quite sure what the value of this config is then. Like, I guess this becomes clear once we look at how an iframe clobbers the JavaScript, like how the, oh, I get it now. I think I get it what the markdown is for. This will create two headers with that ID and markdown, and I believe that will then be part of the config.plugins, config. And so this is the way how you can construct that config variable object, that it looks correct so that then it can load that script. I believe that's how it kind of works. So how are keys and values set exactly? I believe this is the key moment. This is where it uses the markdown, because I think the rendered markdown headers will create like an ID automatically if you render this markdown. I'm not sure how GitHub renders this, but so it creates these headers and or these anchors, and so I believe maybe the markdown renderer on that page creates IDs that match the name, so dependencies and preload and plugins. And then plugins is a link which has then an href. Yeah, that somehow, that must be it, but we will explore it. I think now I've understand this chain, but yeah, we will explore that in a second. We go step by step and first explore like this clobbering, I guess. Okay, so we continue trying to understand this. I just need to run really quickly to the bathroom. I will be right back in just a minute or so. And then we create experiments locally and test out these few assumptions to be able to understand the puzzle pieces that make up this whole solution. Okay, so I will be right back. Welcome back. Thanks for playing. Yeah, the flag and message are still left over from the charity stream from the blind hacker. I have been on there as a guest. That's why I included that message. So if you haven't seen that yet, you can go to the blind hacker Twitch and look at the VOD. I spent like an hour explaining basics of electronics and failing. That's also something that we explore tomorrow. Why I failed with what I was showing there, in case you're interested. Do you get anything from those flags? No. I mean, the idea is to expand a little bit on this, implement more, but it's a time constraint issue right now. Okay, so let's do this. So how do we test this? Step by step. We have multiple. Okay, wait. How do we wait? I need a piece of paper. 1 second. We need. This is complex. We need a bit structure here. So we could maybe use this camera here to take notes. Oh, battery's empty. Careful, Windows sound incoming. Just a second. Okay. All right. So then we can turn this on. And so this is the white paper here. Perfect. Okay, so what we need, so let me maybe mark here the corners that I know where I can write. So we have up here, down here, here, and here. Oh, nice. Got some good space. Okay, so what we need to learn and look at is config, clobber, and the first thing, just like clobber in general, and then the second thing is, now you see my real handwriting here, it's terrible. We need clobber in general, and we need yeah, so clobber in general. Okay, I didn't need to. And then iframe origin checks. This is what I mean with the layers of including different. Oh, this is now turned. Crap. Should have thought about that. Okay, wait, let me flip this. Transform. There we go. Maybe I put this up here. Yeah, okay. White paper of Bitcoin. Oh yeah, Toby, I saw you this thing. I saw your image that you shared with me. I need to review this because looking at it immediately, I didn't quite get it. But maybe we can do this together. Are you there tomorrow, maybe? Or what time do you have time tomorrow? I make sure I stream when you are there, and then you can maybe explain this to me. Okay. Organizers didn't reveal how to solve it. Actually, yes. So wait, this is also kind of interesting. So the challenge author, I believe, or at least who at least knows who is. So after the CTF, you can chat with people in IRC, and people have you can ask them. So and they will release a solution at some point, probably for sure. So let's see. There was a discussion. I'm not logged in and I can't look at the tweets and replies. God damn it. Damn it, Twitter. Crap, what was the other account? So there was a tweet he linked that kind of reveals some of the part of the solution. I jokingly, so during the CTF, because, okay, so at the Congress CTF, at C3 CTF, there was also this web challenge that I made this video about, the XS League, the Cross Search League challenge, whatever, which you can find on liveoverflow. That challenge was actually about a bug that was discussed on Twitter before. And I jokingly said to my teammates, I'm so frustrated, I might just start reading all the tweets and responses and discussions from all the XSS and browser researchers that I know of on Twitter for the past year and try to find things that could help. And indeed, there was a discussion that was part of solution. Now let me quickly try to find this. It just takes a moment. Oh, you linked it. Okay, wait. Perfect. Okay, so this is what Sir Darket linked after the CTF. Okay. So XSS Auditor's default mode is now filter mode. Filter is this where it just strips out certain parts. You can remove scripts that you don't like, make variable defined in one script block undefined, and more. What could go wrong? So this is this config part about abusing the XSS Auditor. And now, Eduardo added, you can also do DOM clobbering attacks on defined variables by undefining them using the filter. This, again, is exactly this part of this challenge here. You enable DOM clobbering. So the mitigation for DOM clobbering is that you define those variables, but you can now undefine them, and now you open them up to DOM clobbering. And they wrote about this in April. But at least this is going to die in Chrome 75. Oh, Chrome's so bad. Why do you use Chrome? At least for DOM clobbering using cross-origin iframe. And so I believe this is kind of the hint that there is a thing going on with cross-origin iframes and clobbering the DOM and doing that name trick that we saw in that exploit that we need to explore in a moment. Cross-origin, but the texts usually are with same origin iframes, aren't they? Yes, most of DOM clobbering requires some DOM element injection, except one, which is going to die soon. This person is not really, you know, like, I don't know, not quite literally saying what it is. You mean iframe? Yeah, you mean iframes, but the texts are too direct. But their texts are to direct them to same origin iframes, not cross origin. Is that what you mean? This is exactly what we see in that write-up, right? The iframes, you redirect an inner iframe to another origin, or to the same origin, to your origin in that sense, and then it enables that clobbering, which I wasn't aware of. I'm thinking more like a Boolean true instead of that. Yeah, and then they talk a little bit other stuff. I really couldn't care more. I really don't care about the resources that it takes. Ideally, it would render everything in a different process and not share any resources and have every origin in its completely own process with no resource sharing. This will just explode my RAM, but at least all the cross-origin kind of like memory corruption exploit where you, I don't know, get the renderer and things like this. Then you have true process isolation. Wouldn't that be great? What's so dark hat is literally exactly the solution. First you set the name, then redirect back to the semi-controlled. Oh, you redirect back? I wasn't quite aware of it. But yeah, okay, so this is kind of... yeah. Anyway, so yeah, so this discussion in April was a crucial part. Okay, so let's test this. I want to see this. I want to kind of like understand how this works. So how can we test this? We just create test HTML files. Point Adventure stuff still. This is the laptop I did the Point Adventure series with, by the way. I guess home. Oh, I'm so scared to... I'm not quite sure what's on this laptop here. I'm so scared. Okay, CTF. Oh, it exists already. Cool. I played CTF with this laptop, I guess. I have no clue. EC3. What is that kind of a CTF? I don't remember. Okay, Google. Okay, so 1.html. Come on. 1.html. Save. It doesn't work on enter. Oh my gosh. Ubuntu is so terrible. DEFCON quals, SNC out and EC3. Okay, yeah, I don't remember. Okay, so I just wanted to quickly test the clobbering in general. So we can do, let's do a script tag here at the top. Learn HTML. Oh my god. We do a script tag at the bottom, and in between we can have something else like input. Okay. So let's do here console.log of a variable called, I guess we can call it already config just to test with this. So, okay, and now we test this. To test this, we just go into the terminal and Python 3, cool. So we get a server on localhost. I just noticed the default serving is on is on 00. It's not localhost. How can I do this? Can I do like this? Oh, bind. It's bind. Okay. Okay. Okay, so here we have our test page. And we look into the console. Okay, config is not defined. Makes sense, right? So that now the DOM clobbering, I forgot, is it the name or is it the ID? So if we define an ID, does this enable DOM clobbering? Cool. Okay, so the variable config is so badly chosen, is now just referencing that element. So let's see. Was name, does this have the same effect or is this just no? Okay. Was name then the effect of the property? This is the worst keyboard ever. Okay, 8. So name a. No, 000 is all interfaces, so it's also like, yeah, not with, yeah. Is Chrome also Chromium? Chromium is like the non-Google underlying, like, yeah. But I don't really care about performance. Like, I don't need. I don't know. I don't care. Okay, so it's undefined. Wait, config. Okay, config.a. I hate German keyboards. Okay, so you don't do this via the name. Okay, wait, how does... paste. The frame name, I guess. Okay, wait, the frame name is maybe different. Wait. I believe, oh, it might be children, right? So if I have like, let's say I have a div. Okay, so div, and now inside of that div, this is the worst computer ever. If I have another, can I div ID inside? Can I then config.x? No, okay, I'm a noob. Okay, this is not how it works. Send help, please. This is worst. With ID, you need extra elements inside. Okay, yeah, so maybe it just doesn't work with diffs in that way. But yeah, our goal is with iframe anyway. But iframe, then it was not ID, it was name of the iframe, right? Ah, this gives you the window of the iframe. Interesting. Wow, okay. That's why this also works. Okay, so this gives you the window, and then window dot something is stuff inside of that iframe. Oh wow, that's really powerful. So you can use the source doc to just define something inside. So we can do diff ID x, for example, inside of the iframe. Okay, no, that didn't work. Okay, so config is the window. Oh no, it worked. I don't know why config. Oh, maybe the source doc wasn't loaded yet when the page loaded. Okay, yeah, so this is how it works. Wow, okay, so see how we created this variable now through an iframe that contains a diff with ID. Yeah, and the write-up using h1 inside of the diff element, yeah. I believe an h1 would also have to have, there's no like implicit ID, right? Or is there such a thing? I don't know. Oh man. when I do stuff like this, like client-side browser, I question like everything that I know about browsers. I might ask the dumbest HTML questions just because it's so quirky. GG, now get the flag. Okay, yeah, cool. Okay, so we understand the DOM clobbering part in general now. Okay, no, wait. One other thing is the mitigation. Like, how can you prevent? Okay, wait. No. Okay, so. Maybe I need to buy a different keyboard for this laptop. This is awful. The markdown converter adds the ID from the title. Yes, that was also my assumption that is what would happen. Yeah, most likely. Okay, so let's say, like this website, how does the website define this again? It's just a config equal. So if we have now here a config, and it's an object with X on it, like that. Maybe we do a set timeout just to make sure the source doc is loaded. Okay, so now it returns la. It's our X object. It's our config object. The DOM clobbering didn't work, but now if we include this in a fake XSS parameter, this didn't quite work. I realized because you need. Let's do it like this. Here's something I noticed about the XSS auditor that I found quite, because I also thought about, I played around with this a bit. So just like this, it is not recognized as an injection. Even though it's exactly the text of our script, this doesn't block it. It only blocks it if you add, for example, the closing tag to it. Okay, no, that didn't work. Oh, no, yeah, it stripped it. Okay, it worked. So now it stripped it out, and now the console is returning, yeah, XSS auditor blocked. Now it's returning again our diff. So this is how you can disable the, can you strip the config variable out, and then if you are somehow able to clobber the DOM, then you get this data. Is it only on Chrome or works on Firefox too? I would assume that this is the same, that this behavior is standard. That feels like standard HTML, the clobbering part. let me get here Chrome. Wait, where's my window? I mean, it doesn't have an XSS auditor, so there's that. But no, not take a screenshot. No. So if we now, it doesn't have an XSS auditor, so this is here this particular tag doesn't work in Firefox like that. But the DOM clobbering in general works. So you can see that that we also with the iframe we clobbered the variables. Firefox doesn't have an XSS auditor. Escape the equal character. That's also what I tried. It also like as you see it works but you need to add the closing tag. It's the same with I tried to add coding first. It was quite surprising. I would have thought that they would detect it, but only with the closing tag it detected it, which I think is really interesting for XSS auditor bypasses, because if you have the thing is, then you already need to have an injection inside of JavaScript. If you have an injection inside of JavaScript, then you might be able to just fool around with the variables, and that should bypass the auditor. Wait, I wonder. Okay, wait. Consider this fake. Wait, I want to test something. Let's say you have a. Let's say you have a function x, okay, which takes a parameter a, alert, which just returns a plus 1 or something, okay? So this is like your function that you have. Now let's assume you have an injection. And then later you call like x with 1. Now is this here? Is this this is our injection? So this calls obviously alert 1. But the idea would be now that we add a fake parameter to. So we are not really building an XSS, we were just testing how the XSS auditor reacts to this. Okay, so if we assume this is our XSS injection, that we injected an x equal alert, basically we change variables, this is not caught by the XSS auditor. Like this injection is not caught. It would only be caught alert 0a would it be caught with wait, this is annoying with the new lines. Let me quickly remove the new lines. It's easier. So the whole thing, though, this should be caught by the XSS auditor. It's not. Okay, wait. Okay, maybe the equal sign is here a problem. What's equal again? 2b? No. It's 3D. Okay, I was just a little bit off. Ah, crap! Now I killed my server. Okay, this also doesn't catch it. Okay, I'm stupid. I don't know. X. Yeah, I don't know. I guess this is not caught. I don't know. Okay, whatever. You see, the XSS auto sucks anyway. Let's get rid of this anyway. I think it needs to be sure that the full script. I also kind of thought about that, but in case of the config, for example, it works with just the partial. This is what I did here. I noticed that if I just have config equal to blah blah blah, that this doesn't work. I needed to add the closing tag. I don't need the starting tag, but I definitely need the closing tag. If I remove the closing tag here, then it's fine. I need to add that. But yeah, anyway. Okay, anyway, so we kind of understood clobbering. Now this iframe thing about the cross-origin thing, this is what I'm really curious about. To test cross-origin now with Chrome, here's how I do this. I get a second terminal real quick. And then we add, I guess I need sudo maybe? Ah, crap. Did it. Okay. So basically, I want to add two fake domains that are both localhost. So let's say example.com and evil.com. So these are our two websites that are now accessible via localhost. So let's create a new script. We call that 2.html. And we create a 3.html. And so we can have, so this will be our example.com website. And this will be evil. And then you can do evil.com/3.html. Okay, this was fail. I guess Chrome didn't honor. Okay, this is awkward. Unique IPs. I believe I've tested this before with the Chrome, the web, the layer, like the web layer doesn't care about the IPs behind it. That is an origin is defined based on the host name here. This is completely irrelevant what IPs are there. Oh, I'm an idiot. I know why. There we go. Port 8000. We were hosting. Command engineer, you were saying server hosting on IP. That reminded me that we did it on port 8000. No. Okay. Okay, so now we have basically two different domains that we can test this iframing with. Okay, so wait. Okay, so now we also need to make sure we replicate the correct headers. Okay, so maybe we need to write a bit more. Maybe we need to use PHP or something. But let's see. If we go to a view page, recent pastes here. Inspect. I'm not remembering if there were special X-frame headers also set. We need to make sure we replicate this correctly. This breakpoint was from earlier. Okay, network. Okay, so the main document. Stop scrolling. Okay, the main document has no special X-frame headers. However, CSP, it might be important. And allows unsafe. Yeah. Okay, we ignore that for now. Okay, so that's fine, but the sandbox domain that is then loaded is also not loaded. There's sandbox here. Let's see. Is sandbox loaded with anything special? Also no frame option. Okay, default frame option, that makes it easier for us. Great. There are shown a text that from the typing sound you can reconstruct because each key has a slightly different sound, and with enough data you can extract that. Not that I really care, it's just like a random laptop here. There's no private data on it. That password is not really interesting, but you know, Gunval also always disables his sound because of that. I still wonder who would be bored enough to pull it off, but yeah. Especially if you have on stream, like me typing a lot, and you see exactly which sounds correspond to what key I'm pressing based on the view. So you should be able to, with a lot of manual labor, like this is still a lot of work. You should be able to. Yes. Yeah, YubiKey just for that is a good idea. By the way, that's also why fingerprint. I like to talk about it. I think this is always good to think about. So if you have phones with like fingerprint sensors, like people say fingerprint sensors are insecure, but it solves the problem of shoulder surfing. So if you are standing somewhere, nobody can shoulder surf you, enter your PIN, because you just use your fingerprint, you know? So there are use cases where maybe it makes sense. Anyway, okay. So wait, what do we want to do? So in our case, first of all, example.com, let's make a, okay, let's make another harmless, just like a random, well, let's call it maybe 2_1. Okay, so this is supposed to be a site that example iframes. Okay, so and it's on its own domain. Iframe source. Is it source or is it href? It's source, right? So it would include 2_1.html. And let's do let's also add a script here to output the we want to test the eventually we want to test the clobbering, right? So let's have a script up here with config equals to like save, and our goal is to change that basically. And then we have then we just make a test function that will just if config is equal to save, then let's say if it's not safe anymore, then we do an alert success. Okay, so because so this is simulating the real challenge has this message passing between those iframes that can be used to trigger the re-rendering of the content, and that re-rendering then goes through the config and loads these scripts. So this will not happen on page load, or it will also happen on page load, but you can re-trigger it through these message passing because this iframe gets loaded like afterwards, and your tag will change and clobber the names afterwards. So this button press is basically by hand now our message handler. When we believe we have done our clobbering, then we trigger this with a button press. Okay, so this is kind of like our test site. So we need a button on click test. Okay, so let's check this out. So here we have evil, and then let's make this example.com, and this should load the second HTML. Okay, I guess we can also close some stuff here. Okay, so if we test now, nothing should happen. Fine. Okay, so now let's see. The idea is now, the attack idea is that we want to clobber the config of this page here. We can't directly do this because we have no injection here. But what we can do is we can iframe this page inside of from our evil domain. Like evil is just our website. We can control this. So what we do here now is we iframe example.com the 2. Okay. Port 8000, of course. We need HTTP. Shouldn't on-click, I think so. Ah, yeah, okay. Well, I don't know, like I'm a noob. Okay, so now our evil website is iframing example, which iframes itself. And now let's see what we can do with this. So now we are, so if you didn't know, in the JavaScript console, you can say, you can define in which context you want to execute JavaScript. So if you want to execute this on the on 2HTML, so this is our example page. Obviously there exists config. Okay, so this is the HTML world of that one. But our top, this is our website that we control, and there's obviously no config. Okay, so but now the idea is that document.frames, no, window.frames. Okay, so frames, so there's the first, we get our iframe. So this should be the first iframe. Can we access its location? No, we cannot read the location, I believe. Or it's just, okay. So we are not allowed to read the location. Why is this important? I don't know the historical reasons, but I believe the reason for that is that sometimes websites include, for example, the session token in the parameters, or in general, sometimes there's secret stuff in the parameters that you don't want to leak. But if you could iframe another site and then read the URL, you might be able to steal that from the URL, right? So it's important that the same origin policy prevents us from reading the location, the correct URL of the, I believe that's how I explain this to me. However, it's writable, so we should be able to assign a different page to it, and we can redirect it, for example, to http evil.com port 8000 slash, let's make also another evil site here. So 3_1. So so if we do this to 3.1 HTML, then this should work. So we are allowed to redirect that page. We are just not allowed. We are allowed to assign, but we are not allowed to read the location. Okay, cool. So now apparently what you can do is, from inside of that frame, so window. Okay, yeah, it is already the window object. You can access its frames. Apparently. So now this should be theoretically the child frame. So we do this twice. We go the frames down. yeah, okay, so now we redirected, as you can see, we redirected the inner iframe, so this is allowed. And so now let's see. If we would try, okay, so this is the one code, so we need to remember this. Okay, so the next thing is, are we allowed to change the name of this iframe? No, we are not allowed to modify the frame's name because cross origin. But which origin? Is it blocked because of the first layer here? Because this is the iframe, so we access the iframe of this layer, or is it because the child iframe that it belongs to is not allowed to change its name? So the idea is apparently now, if we change the location to our domain, now this inner child and our outer thing is the same origin. So this outer should be allowed to access the inner frame's document. So see how children, see how we are allowed to, so you are not allowed to access the children of the, so oh my gosh, I hope this is not too confusing. So window is our evil side, frames 0 is our example.com. So if we would try to access the document of the site that we have iframe to example, that is blocked by the same origin policy. But example.com now iframes our domain again, so frames of that is allowed. So we can access our own domain content. So we can access inside of there. And now the idea is, so after we change, we redirect the inner one. Now we should be allowed to change the name to ASD, and that should be great now. Cool. This changed now the name. And now if we go inside of example.com, so now we are in the context of example.com. So in here we have the config, if you remember. If we access now ASD, we access the frame's name. Through that we clobbered now the variable JavaScript space of example.com, even though we have no direct access to it. And so now it makes sense, right? If we DOM clobber config away, so let's say we are iframing, let's see, wait, we need to be able to clobber that away. So let's go here again. Example.com. So let's take this whole thing and add that as an XSS. Okay, our test doesn't work. Oh, yeah, now it's not defined. Okay, great. Okay, so this works. So if we iframe this now by evil, so we change this to this. Okay, so now the XSS frame blocked the config. So inside of example, so we changed the context, we are inside, there's no config now anymore. But if we now execute basically a tag, we change the location, we add the name config. Now, if we go on this site's button, okay, it doesn't do anything. Okay, wait, maybe we did the handler wrong, the click handler, but doesn't matter. So now we are in example context, and now there should be config again. So config exists now again. Isn't that cool? It should be test. Yeah, you all are noobs with HTML. Clearly, it must be this. You were wrong before. Bans incoming. Okay, cool. Okay, so this is awesome. So what we just learned is how that we can clobber variables. That was fine. We can use the XSS auditor to disable variables that were already set, and we can abuse nested iframes, which we redirect an internal iframe to our domain. Then we can access the name and we can clobber the context. So now for the CTF challenge, that means we can iframe a view. We can redirect the inner iframe to our domain. The iframed view needs the config to be disabled by the auditor. We then change the name of the iframe, which clobbers the config. And then comes this other part of the challenge. To trigger the re-rendering, you need to be able, and that's, I think, the other thing I need. Crap, I closed Sublime. And so if you look at the code, so render, so there's this renderer. The renderer sends a message from the content window, a post message, to render again. And then we have this on message handler, which is here. It receives that message. It removes its child ports. And then, oh no, this is not what we want. This is not the re-rendering. I believe, I believe it's triggered on an error. So if the parent receives an error message, so if the child iframe, like the sandbox iframe, sends an error message up to the main page, then it will init and load the plugins again, and that will trigger the looking again at the config and loading those scripts and then executing them. So, and how do you trigger this? So this was the other thing. It just is an event listener for message. So I believe, so we can test this, I guess, really quick. Can this site also be accessed? Okay, cool. Thanks, Google, for also making non-HTTP thing. That is super helpful. So the idea would be, let's go to our, I guess, here. Let's make a new one. Let's save all those tests. For.html. So if we iframe this, no, I want to, actually, I want to, okay. So I just want to, so we iframe this view here. I just want to test the post message if we can send that. Probably not, right? Can we send post message cross origin? Probably not. I'm not so sure. That's what I kind of want to test. Okay, so okay, yeah. So this is the next point. So post message cross origin. This is kind of like where I'm like stuck right now. CMD engineer. It's really good that they don't use HTTPS because SSL makes working with some tools like web proxies kind of difficult. Browsers also prevent interaction between SSL websites and non-SSL websites for security reasons. But in CTFs, often you need to have your own domain or you host your own files. Like this challenge requires you to have a web server running and that serves these kind of iframes and these files, these HTML files. And so if your web server doesn't have, if your test web server during the CTF doesn't have a valid SSL cert, then the browser will refuse to work with the site because now you mix SSL with non-SSL and that causes then issues. And so it's just a hassle for CTFs. Then you need to make sure that you have set up a domain with a valid certificate. And this is all fairly easy today, but it's unnecessary, right? It just adds an overhead for the challenge creations that is annoying. It also doesn't matter that it's like it's not the official google.com domain, right? The CTF is on its own domain, so it doesn't matter. Oh, thanks for the Twitch Prime TPG stream. Okay, so the post message. Okay, so we go to our no, not one, 4.html. Okay, so we paste static. Okay, so Mozilla post message. I forgot how to do post message. Oh, I don't. I would just want to copy and paste it. Okay, so there are also some security concerns. We read that in a moment. I just want to test really quick. So, okay, we need the window. We need the iframe. Okay, so we get the window.frames. So this is that window, and now on there is a post message, and then the first message. So if we basically, I want to test out sending that error message. So we need an event object that has data, that has a type, and that is error. And lang is whatever. And so now we go into the sources of the PayStatic website, app.js, and we set a breakpoint at the message receiving. So let's trigger this again. Doesn't do sheet. Yeah, I played the Google CTF. Imagine Google turning off SSL on google.com just for the CTF. Would be highly appreciated. Do I need the origin? Okay, so wait, I would then add the origin. Can you access the origin on the iframe? No, okay. So the origin would be this. Oh yeah, okay. Wow, okay. So now we are in here, and then we can so we can see what came in. EVT is not defined. Oh wait, we need to go in here. There we go. Data. Okay, so data is exactly what we came in. So this would now execute init and load script. Okay, so this is how we can re-trigger this. So if we, just as a test, I'm overriding now. Config is still like fine, right? Config is our variable. We didn't do any attack on here. I just want to replace it with something else because it will trigger some errors, I assume. So if we let this run, yeah, cannot read property 0 of, so this triggers a re-rendering and then fails when it wants here to access the config.viewer. So this is how the evil side can after all the clobbering is done and the changing of the iframe, it can re-trigger the rendering now. Loading the plugins. The loading of the plugins would download your script, would eval that script inside of the sandbox, and that eval sandbox is just a script, can then send back the cookie. This should be the whole solution of this challenge. Okay, we are kind of so close. Almost we should be able to. I'm curious, why does this not work, this exploit then? Because based on all of that, all of this should have worked. I'm really curious why apparently this has not worked. Oh, why this has only worked locally why Katie wasn't able to exploit it. But yeah, this is good enough for me. No, it's good. It's okay. Oh, they finished 30 minutes late? Ah, okay. Awesome. Okay, yeah, cool. So I'm quite satisfied with that with right now. I might wanna just like execute the full exploit at some point myself, but I wanted to take you along a post CTF kind of way. Like, you play the CTF, which is great. You learn during the CTF, you explore stuff and you get stuck. And this post CTF is equally as important to revisit the challenges that you failed at or that you are just interested in, and then looking at write-ups to various degrees, however you feel like. And so I feel really good now about Paste-tastic. I feel like I completely understood how this challenge has worked, and I got now the experience of these couple of like tricks that were abused to make this whole thing work. And so this is how I basically feel now very confident about this particular challenge, right? So I did now my part of the post CTF write up thing for this challenge. So I'm quite happy with that. Okay, so what else? So this was one. Has anybody seen a write-up for the JIT challenge yet? Yeah, so the other challenge that I would be interested in, because I spent a bit of time on, would be the pwnable JIT challenge. Also got quite a few solves, so I assume that at some point we will definitely see write-ups, but I'm not sure. There was a write-up. Okay, cool. Let's see. This is the other thing, right? You need to find these write-ups. So let's maybe look at CTF time. Has anybody looked at CTF time yet? If somebody has submitted one. Past events, midnight, CTF. How is this not here listed? Google CTF. Yeah, that's the other thing. Might also not be out yet. It takes time to some write-ups. Wait, isn't there a link usually? Or does it only show up when there are write-ups? Dev. Wait, let's just copy this. Okay, excellent. Thank you, Kartoffelpuffer Overflow. By the way, for non-Germans here, Kartoffelpuffer is a meal or a dish, and Puffer is the German translation for a buffer. So that's the joke there. Were you able to get a shell of the binary disregarding the Java sentence? No, I didn't. I had no success with exploitation. Okay, so maybe quick recap. I mentioned it earlier before what my progress of JIT was. We can also, I think I downloaded the files, right? So there was this Java file which basically just executes a compiler binary. This Java file just makes some sanitization of the input. The input that you can send to this program, to this binary, to the service is, for example, something like this. So you have a couple of instructions like move, store, load, sum, return, compare, jump. So you have a couple of instructions, and this Java tool, the Java part just does some sanitization. It parses your input string and validates it. And when that is fine, then it passes that input to the C program. That C program takes that input in run, and it compiles each of these instructions that it gets, and it does this by basically a big switch case statement, where it or a lot of if cases where it compares the commands that you passed in, and then it assembles raw assembler code. Like this assembles actual like assembly shell code, binary code. So it basically compiles the text, your text code to real code. That's why it's JIT, just-in-time compiler. It compiles that to actual bytecode. It writes that into a memory section that is executable. Or first it was writable, and then it changes the protection to executable. So now you can execute the code in there. And somehow there must be a bug. So somehow you can corrupt memory, write outside of this memory protected area, and change some other stuff in the program. Various ways how this might look like, I don't know. So the only thing I did, so I didn't spend too many hours on this. The only thing I did, I was instrumenting this binary to run with AFL to fuzz the input. Problem is, of course, that real input must first pass the validation of fancy JIT Java program, which is very restrictive. However, I didn't implement the full sanitization. I basically just restricted the types of characters in the fuzzing. So basically, I modified this program to first sanitize the input to make sure that it only contains the characters that are allowed. But even that generated obviously a lot of invalid input that caused immediately crashes. Like running AFL on this immediately causes so many crashes. But the problem is that all of these inputs are not valid from the fancy JIT validator. So either there's maybe a fancy JIT validator bypass, or there are combinations of these things that lead to some kind of other exploitable condition. So this is as far as I got. I never explored any of these crashes more because I knew that the input is invalid. I would first need to find something else. Basically, that's all I got. And I believe in the register RAX was some kind of address that you can like leak or can work with inside of this code. So register A, so here immediately it writes register A, but if you remove that or just return A, then there was I believe there was an address if I remember correctly. But that's as much as I know. And so I spent a bit of time on it and then gave up and worked on other challenges. But so I'm also still curious what was the actual solution of this. Wait, what happened? You were talking about the buffers. Wait, what? You had the idea, just stopped short. Are you talking about the paste thing or the JIT? Okay, anyway, so let's read this. I have no clue. Okay, we read on the internet that Java is slow, so we came up with a solution to speed up some computations. We are provided with two files, fancy.java and compiler.c. For this challenge and from the description and a quick look, we can see that fancy.jit class reads in opcodes line by line, performs some validation, and then sends it to the compiler via a natively built shared library. The compiler then parses the program and converts it into machine code, then executes it, returning the result to the Java program. In order to compile fancy JIT, we first need to download the JNA library. Okay, so I already failed this. I tried to compile this fancy JIT file, and then I didn't have JNA, and then I tried to install JNA, and then the compiler, then Java C still didn't find it, and then I gave up. Oh, you just had to set the class path directly to the JNA jar. That would have worked. Yeah. Java noob. But small things like that obviously then led me to kind of like give up on this and do something else instead. There are only 11 opcodes, which are all fairly basic. Still more than the 8-bit CPU that we are building usually on stream. Like adding and storing, but there are also compare and jump operations for performing loops. The compiler maps two random pages, one for the executable text section and another for data, which stores into R12. All of the opcodes for accessing memory generated code to use this register. For example, load will generate a move AAX of R12. The load and store operations seem fairly safe, and there didn't seem to be any way to access data outside of the page. My next idea was to try to jump to the middle of an instruction as the move instruction. This is another idea I had. I thought about, and it also looked like that a lot of some of the crashes that I got, I looked up a little bit at the crashes I got, that maybe you could jump in the middle of an instruction. That's also an idea I had. Allowed us to use 32-bit value, which would allow for 4 bytes of assembly. If we use the last 2 bytes to jump forward, then we could chain as much ASM together as we need, as long as they were... Oh, right, that's how you could build this. I completely forgot about this ability. Is that the solution? Is this basically what they are doing? Damn. Okay, so one of the very first CTF challenges that I've ever, oh no, not the very first CTF challenge, but the first real CTF challenge that I've ever solved, or the first like hard CTF challenge, the first challenge I feel like really proud of, okay? A challenge that, this was the first time in a real CTF I solved a challenge, right? A real challenge. It sounds bad, but I'm really proud of it. Was SHA-1 code. This challenge. This is what I solved. This was my first like real challenge, and I was so proud at that time. So the idea there was basically the same. You were able to inject, you were able to input data, and the data would be turned into SHA-1 hashes, and then it would jump to your SHA-1 hash. And so you obviously can brute force SHA-1 hashes so that certain bytes are valid instructions. But the more bytes you want to use of the hash, the more you have to obviously brute force the SHA-1 hash, and you can't have like arbitrary code. So what you would do, you would always brute force SHA-1 hashes where the first few bytes are only like valid instructions, and it would always execute something and then jump to the next one, execute something, jump to the next one. And it sounds like this here is basically the same idea. You can jump in the middle of a move instruction, and you can control that little bit of part. I guess like how many bytes? Like 3 bytes or so, maybe. Allow for 4 bytes of assembly. Okay. So it allows you for 4 bytes of arbitrary assembly. So you need to have like, I don't know, 3 of those can be some assembly you choose, and then 1 byte needs to be the jump to the next move instruction. If that's the solution, that is something I could have solved. Like, right? I just didn't have the correct idea when looking at this, but it's so similar from the concept, like the very first challenge I've ever kind of solved. So that's kind of a bummer. Kind of feel bad about that. Okay, yeah. That is exactly what the solution is. Oh, I'm annoyed. Oh man. I could have solved it. Also, nobody of us solved this. Like, nobody had this idea from our team. It doesn't have to be a jump. Oh, just an effective knob. Yeah, that makes also sense. The shell hashes were obviously way longer, so you had to jump. But they are here, it's just a single byte or so. So you could turn the last byte into a knob that consumes the next byte. And then, yeah. Wow, that makes so much sense. Damn. Okay, so let's read this write-up. I realized that result was being put into out4, which is only 1 byte, meaning we can overflow it to potentially remove the 5 byte alignment. Oh wait, there was also an alignment thing that you need to... Okay, wait. So jump 0 would create a jump to offset 0 from the page, and jump 0 to offset 5. Wait. I believe this is a typo, right? That should be jump 1. Jump 0 jumps to 0, and jump 1 jumps to 5. I realized that the result was being put in out4, which is only 1 byte, meaning we can overflow it to potentially remove the 5 byte alignment. Not a typo, scroll up. Oh, okay, I'm an idiot. Okay, wait. Okay, my next idea was to try to jump into the middle of an instruction, as the move instruction allowed us to use 32-bit value, which would allow for 4 bytes of assembly. If we use the 2 bytes to jump forward, then we could chain as much assembly together as we needed, as long as they were 1 or 2 byte instructions. the jump calculation out for. Oh, I'm an idiot. This is what you mean with move forward. Okay, wait, where's that code? So this is code in the compiler. The jump instruction is here. Wait, okay, it creates like a weird jump instruction. Online disassembler. Okay, so this is E2 01 C3 EB, and then out for is int bracket. Okay, so this is the integer in that is jump. The jump instructions like jump bracket open number close. So that number minus instruction number. Okay, whatever. Okay, so now it creates a 5-byte alignment. So it jumps. The number is always times 5. So here it could be a number, for example, like with a 5-byte alignment. I don't know, like something like this. Okay, so loop 3 is, why does it do it that way? I don't understand. Does this have any sense? Why? Where does this jump to? Loop 3 loop 3 is just a jump, right? So it just jumps over the red. Why is it done that way? What is the? I don't quite get the reason why the jump is encoded in that way. That's. So this was from Clobbering to test with. We can have a look at that in a moment as well. So the program will eventually terminate. Oh, it's like kind of a safety instructions. Like, do you have these loops throughout other instructions that? Wait. Okay. Wait. I'm confused. Does this loop show up multiple times? Oh yeah, basically every code has it. Okay, so I understand. This is kind of limiting how long the code can run. Here, so you can't build an endless loop because it keeps decrementing that counter, and so you only have limited amounts of loops that you can make, and then at some point, so that 3-byte snippet is just there to prevent the denial of service, basically to limit how long to have it to how it run, right? Okay, so that makes sense. Cool. Okay. And okay, so basically each compiled instructions is also a line of 5 bytes. This is also something I didn't quite notice, except single byte instructions. Oh no, they are not single byte. They are 2 bytes here. But a lot of these instructions here are multiple bytes. And now the move instruction, a move instruction is also 5. It is 1 byte for the move opcode, and then followed by 4 bytes in int. So followed by 4 bytes of the integer that you give. It's also 5 overall. Okay, so this makes sense. So this is aligned. Okay, so we understood this now. So let's continue. How do you break out of this alignment? So jump 0 would create a jump to offset 0 from the page and jump 0 to offset 5. No, this is a typo, right? This doesn't make sense. Jump 0 would to 0 and jump 1 would to offset 5. I realized that the result was being put into out 4, which is only 1 byte, meaning we can overflow it to potentially remove the 5 byte alignment. For example, if we use jump -5 1, then we are at 20, we get, yeah, okay, I understand, that makes sense. We get truncate to -1 and 4 and resulting in a jump to offset 1. Okay, cool, that makes sense. Okay, yeah, that's the typo I meant earlier, and then you said scroll up, and then I was really confused. But yeah, okay, cool, I understand now. I understand why there's an alignment of 5, and this was a typo, and how you can get, this is basically the trick. This is like the bug, and the rest, this is the bug, and the rest is just like making it work. The jump can now be used to go into the middle of an instruction. For example, we can use morph to encode our payload in 2-byte increments. All right. Yeah, cool. I then tried to run it through FancyJIT instead of straight in a compiler, but was greeted with sorry. Oh, okay. But the validation for move and jump, we see that there are some checks on the arguments. Okay. And so in this example, it was a negative jump 51, and jump has here some checks, an absolute check of 20. So both our move and jump instructions fail the validation as they are outside of the allowed range. I started looking at the ways to bypass the validation, but was not able to find any and none of the instructions had incorrect validation from what I could see. Oh, okay, so there's a bit more twist. So now I feel a little bit more better about not having solved that. There seems to be a bit more involved. Still mad that I didn't have this idea of jump. Well, I had the idea of jumping in the middle of instruction, but I didn't follow that thought further a single bit. I basically immediately discarded that again. I didn't even realize that there was alignment. I never looked at it that deeply. I then start to look for a difference between how FancyJIT passed the program to how compiler passed it. The function directed the argument value. Okay, so there's another bug, I guess, in the parsing. Oh, the code you sent me will fail the Java validation. All right, cool. If we could somehow send in character other than 0 to 9, then the compiler's int bracket method would be incorrect. And as there's no length check, we could also overflow it. I tried a few different things like these kind of, but int parse int always threw an exception. Okay, so his or her first idea was to try to abuse like parse int in Java. I went and had a look at the source for parse int, which led me to character each digit. This had some very nice Java doc giving us a clue as how we can get another character through validation. Amazing. So certain UTF, like other characters in different languages, Java says it's a digit, and then of course this causes then issues in this loop here. And these different integers would count as a 0. Oh, that's awesome. Using these, we should be able to craft a string that is correctly passed by parse int, but then produce different number in the compiler. Oh, that's awesome. As this was a CTF, I just wrote a quick and dirty function to brute force values that the compiler would see as our target number, but the FancyJIT would see it as less than 100,000. This was done by generating random combinations of valid UTF-8 zeros until a number that was within this range, and then appending the last 5 digits to make the correct number. The next step was to generate a valid argument for jump that would equal to -551 in the compiler. The issue here was that the number had to be within 20 of the current instruction pointer to pass the validation, but we could only have 23 instructions for the value of -51 to still jump to the correct place. I changed the above function from 100,000 to 1,000, set it running. the values I had picked weren't really set in stone, so I started changing the generator to search for other values that could be used with some padding and jumping around, and then and then one was found, which is 13 when validating and minus 51 when compiling. Holy crap. That's crazy. The final stage was putting it all together and create the shellcode. I decided to simply protect and read as the first stage, then I could just send through a second stage payload with the remaining shellcode. After a bit of time calculating random numbers, we get a shell and then the flag. I like the German umlauts in the solution flag. Nice. Nice. This also unifies an idea, like one of the CTF challenges I thought about creating at some point is also this mismatch of parsing special characters and then have some other thing validated and then passing it to C that then just handles it differently. I think that is a cool challenge too. That is a cool challenge. I like that. And there was a cool solution with wasn't as simple. There were some cool twists to it. I like that. That was cool. Okay, cool. So this was the other challenge I was really, really curious about. In the end, they made Java faster or not? No. They extended. They added a feature to Java. So this is like an official Google product that extends Java with some JIT capabilities of some custom code that you can use. But it also adds like this feature that you can run also arbitrary code on a particular host. So it's really cool for like enterprise applications. What other challenge could we look at? How long have I been streaming? 2 hours 42. Oh, that's not too bad. I feel like we got some good. We understood 2 challenges, the solutions for them in that time. I think that's good. So these were kind of my challenges that I looked at. Was there anything else I'm interested in? Oh, has anybody a write-up seen for the remote control challenge? That is maybe, I looked into that challenge even less, so I basically know nothing about it, but I think reading a write-up would be cool. Or anybody else, has anybody of you played the CTF? How did it go? What kind of challenge were you stuck at? I don't know, maybe we can just have a little bit of a chat like that. Those were mainly the challenges I tried, and I wanted to look at how they were solved. You're looking at GoPhoto now. Was that the SQL injection one, GoPhoto? With like really weird SQL injection? Crypto ones, forget it. Crypto ones on CTFs like this, you need to be such a math pro. It's so we have some really good people in our team that know math, and so just listening to them is I could listen to them talk like for hours. How they think about this with those mathematical terms from university that I didn't even have math to that level, and I struggle with math, but it sounds so fascinating. I wish I would understand what they are doing. It's probably also basic. I don't even know. It sounds super complicated and crazy to me. I'm a math major, but it's still really basic. The CTFs is basic math. Oh, god damn it. Yeah, I assume it's probably simple math. It was all terms that I heard of, that I knew, but it's like at university I only was able to kind of pass the exams. I never got to a level where I could kind of like have a broader sense and understanding of the mathematical concept that I was learning to be able to apply it. I still struggle with a lot of mathing. It's one thing that makes me really annoyed, and something that I feel like I want to try again some later point. Maybe try to work through some introductory math courses again. I mean, there are many lectures uploaded on YouTube that you can follow up from professors. That's kind of like a big to-do that I want to do at some point, because it really annoys me. I think math is great, but I'm so bad at it. I was also a bit too slow, I felt, for university. I was just dragging along, I don't know. That was the order bias injection. Yeah, I didn't look at it at all. My teammates looked at it, and they solved it. I think that was a challenge they solved like 4 minutes or so after the time closed. There was some typos in the scripts and a couple of other small mistakes they made, and then they got the flag like 4 minutes or so after the CTF closed. I believe that was the challenge. Yeah. I didn't look at any of the beginner challenges, but I would assume or hope maybe that Gunvael makes a stream like the last year going over those challenges. That would be cool. But I don't know. I haven't talked to him. I don't know if he does. But last year he went through all the beginner challenges. So keep an eye out for Gunvael. He might do again a stream about it. Gunvael Ian on YouTube. Even if he doesn't do it, it's a good idea to still subscribe to him, I guess. Yeah. Anyway, did anybody play the Google CTF for the first, play a CTF for the first time? Anybody who is like right now? Tried out CTF for the first time? I would be curious about your experience, like with the beginner CTF or the normal CTF. Did anybody have some favorite challenge or a particular cool solution, or saw a cool write-up or anything else we could look at a little bit? Oh, chill, dude. How did it go? Did you play completely alone, or did you team up with some people? Your pulley solution is pretty ugly. What was pulley about? I have no clue. Wait, pulley wasn't it hardware? So what was pulley about? Okay, that doesn't tell me anything. What is this about? Oh, this was the bias image that I can load into Chemo that was sent. I think I saw your tweet about the solution. It was like, it has to be ARM and x86 at the same time. Okay, so give me a bias image that I can load into Chemo that will pull that lever 1 to this, so this as characters to this IP over TCP. The server can be delayed a bit, so your payload should retry connecting. And by the way, it has to work both in x86 and on Chemo, all in under 300 seconds. To make your life easier, there are commands the server will run. I wouldn't even know how to start this. I saw your tweet about that that ARM expects the reset vector at address 0, and x86 expects it at the end at FFFF something. So it's kind of simple to have that as a if gate, where to jump to different things. So that sounded cool, but I still would have no clue where to start to write that kind of low-level code. That sounds like I have zero. Do you have any recommendation how you would, or how did you approach this? I've never written this kind of. I assume this is like very low-level code, like low-level hardware interaction, isn't it? If you want to able to use the network, don't you have to somehow use? I have no clue how a bias works on that level. How can you? Does the bias offer you network capabilities that you can then somehow use? But I would have zero idea how to approach this. a U-boot. You built a U-boot for ARM and x86, made virt.io. Okay, so that virt.io is, I assume. So is that like a low level? No, okay, wait. I don't know what this is for. I saw U-boot doesn't support TCP, but you found a patch set implementing wget and TCP. You need a bunch of stuff for virt.io. PCIe to find the devices, then virt.io ring buffer code, then virt.io net code on top of that, then a TCP IP stack. So the patch set that you found for U-boot were basically adding virt.io to U-boot. Is that understand it? Okay, so virt.io allows to run any operating system virtualized, so it's slower because the hypervisor has to emulate physical devices such as network cards. Oh, okay, wait. Okay, wait. Okay, so wait, what is the role of virt.io for? Is Qemu using virt.io to do the networking stuff, and that's why you looked into how to how to talk to virt.io, or am I understanding this correctly? Okay, Qemu uses it, yes. Gotcha. Okay. So, wait, virt. Maybe did we see that in the parameters how it's executed? Wait, where's my window? So, oh yeah, it uses virt.io. Gotcha. Okay. No, wait, that's the machine name. Okay, whatever. Maybe it's just, yes, it gives you a virt.io net device which you can use in the quest. Okay, and how do you interact with such a device? You don't do this yourself. You just use what, for example, U-boot has implementations to talk to that kind of device. Or is that, or are you actually writing code that access so low level to these memory buffers? So the code snippet you found that patches or that adds TCP to U-boot basically just acts on these buffers that you are mentioning, are interacting with. U-boot already has drivers for these. Actual PCI interaction. That's why you use ready-made. Writing the code from scratch takes a long time. Yeah, I would understand that. Well, I don't, or let's say I don't know. Like in my head, I also would hope or would think that you would reuse something because it seems crazy, but I don't know. Maybe it's as simple as there are some. I really have no clue about this kind of low-level assembly, so I thought maybe there's also like, I don't know, a TCP opcode or something that then something else can handle, like it triggers an interrupt or something, and then a BIOS. I don't know how this works. I don't know how this low-level stuff works. Yeah, move AX IP TCP. You thought about writing it from scratch, but then I got the idea to use U-boot. It seems a nightmare to kind of like assemble all of that together and make that work. Like even like reusing other people's code for something like this. Maybe within the Intel ME. No, I don't. Okay, wait. Obviously, this is completely wrong what I'm saying, but my imagination was kind of that you on this really low level when you're interacting with devices, like a BIOS can register handlers, like almost like syscalls to do something with a piece of device, and so you would then write just code that like triggers like a syscall, like a special instruction, and then you give it a number as a parameter that says then, okay, I want to talk to the network card now, and the BIOS handles then how the network card works. That's kind of how I imagine it, but I don't know. How do you get it to work on both ARM and x86? You have to ask BangPow. I saw BangPow's on, like, if you have, I'm not sure how I can find your tweet really quick, but you can post, BangPow, I believe, has written on Twitter a short tweet how he has done it. I think the idea was that ARM has the reset vector. So basically where ARM systems start executing is basically it expects it at address 0, and then apparently x86 expects it at the end. There's the leaked. Now we know who you are. So where you had to write an ARM and x64 BIOS running in QEMU, which need to send a magic string, talking U-boot port by taking U-boot, applying a patch which implements wget. Wait, that was in the next tweet. Making the BIOS run x64 and ARM was easy. ARM looks for the reset vector at 0 and x86 at FF0. Means QEMU maps it at the lower memory end on ARM and higher on x64. So you can just concatenate the two as long as you keep some alignment constraints in order. Just pass a small file to the x86 QEMU and will error out when loading the BIOS. The ARM QEMU will happy execute the file at 0. Cool. Yeah. So in retrospect, again, it feels doable, but I feel like this is a challenge where that would me cost, like, even if I know now the hints, it would probably still, at this point, if I would attempt it now, would probably easily take me like 12 hours or so, probably. Making all these different, like, getting U-boot to compile and then merging those two together. I don't know how this mapping works, like what kind of the bias kind of what QEMU expects as a file format to where it maps what. I don't know. It was easy, although fiddly. Yeah, and I think fiddly is here the key point. I assume it took me hours to make Writeups network device work. I can imagine. You had to use commands to scan all the PCI devices and then the virtual devices. Oh my gosh. There's no documentation about this at all. You know, and I struggled with the documentation for the Minecraft clone. For the mind test challenge. Yeah, maybe I upped the numbers. Maybe even with the hints, I would need now 24 hours or so. Cool. Cool. Yeah. Anybody else? Something to share? Something to talk about? What kind of button? What does this do? Oh, never mind. Haven't tried the mind test. Was it interesting? Yeah, mind test was kind of fun. I did it because crap. Yeah, because it was posted. Oh no, this was here. So it was like a mind test is like a Minecraft clone, an open source clone, and they implemented these kind of logic gates. So it was quite fun. But it was also straightforward. Like, you had the world file, which has to contain all the information about the blocks. It's open source, so you can look into the source code. They have documentations on how these world files look like. It's an SQL database basically that you can parse. that contains the world. So the biggest struggle I had was parsing that file, because in the way how the world file is structured, there are these binary blobs, and these binary blobs encode then each node, and each node is an actual block in the world. And I had troubles figuring out how to know the orientation of these blocks, because you need to know if the wire takes like a left turn or a right turn. So you need to know how this is angled. So yeah, that just cost time. So it was straightforward. I knew what to do. You have to just somehow extract all these logic gates and all these connections, get that graph basically out, and then you just need to put it into a format to solve it. And it's like a prime example to use Z3 to solve this. So it's like a typical challenge to let Z3 then solve it. So in case you don't know, Z3, you can just like, there's other examples. I don't know. Basically, you can just define the whole formula. Yeah, okay, not good examples. Anyway, it can solve like this graph for you. What are the inputs? Yeah. Oh, and I haven't discussed the Writeup remote control. Do you have a Writeup? Because I don't have a Writeup for it. You are considering buying the Ben Eder set, but shipping is pricey. Yeah, I had the same issue. That's why I didn't order the set from him, but order the parts myself from different sources, which was a bit tedious. If you send me an email or write me a Twitter DM, I can send you my parts list, but it's not cleaned up, and it's all not great. There are some parts that I want to replace. I have again a shipment coming in tomorrow with some other parts where I play around with. So if you are in no hurry, then just wait a bit until I have a better understanding of the parts that I've actually used for my build. I can give you a list with all the stuff where I bought it from. However, I can still give you the current status, which is not quite this. And yeah, and Toby Plus made like a DigiKey parts list, so that's also good. I'm struggling with the beginner challenge. I netcat to a Linux machine. No, the chat moved. Had to read the content of a file. One problem is that there's no program to read files, not even Hexdump or any software like that. That sounds like a fun challenge. A busybox minimal with basically that's kind of a fun challenge. Strip out everything and make a simple thing as just read this file, but you offer no way to do it except with like it need to be a bit yeah, that's kind of a cool challenge. That sounds fun. Still not. Yeah, let's see. Remote. Wait, how is it written? Chill dude, just FYI, when you ask about commands, what they do, please just do always this as a first step. Type in man for manual and then the command tar, and then you can use your arrow keys to like scroll up and down, and then you can search for what -c does. And you can, yes, it requires maybe a bit of reading here, but you can see where -c shows up. So here are the flags explained. So -c creates a new archive. Arguments supply the names of the files. So it's a good idea to get used to using man pages. Yeah, and you can leave that with pressing Q in case you get stuck. Why does it show the content though? I don't know. I guess that's just what tar in that case does. Oh, it prints to std out. Yeah, right. I remember. If you don't specify an output file, then it's just to std out. Yeah. So man tar again. Let's see. So it probably says it somewhere that it just outputs to std out. It only worked for the first flag. What happens with the second flag? I assume, yeah. Tar might, my assumption, I haven't tested it now, my assumption is that with the very short flag, it does not really compress it because it's too short. And so the compression added to it just doesn't help much, probably. And then maybe the other flag is longer and then it does compression. But then the output, oh, that's okay. The second one is a permissions problem. Okay, then never mind. All right. Yeah, I don't know what I'm talking about. Ignore me. Cool. I think it's good that you discuss in chat some of these challenges. Good job. Good job. This is also the kind of this. What you see basically right now in the Twitch chat is basically what happens on the IRC channel right after the chat. So I can just highly encourage it that when you play a CTF, look around for if you can find the the official IRC channel of a CTF, because after the CTF, these kind of discussions about the challenges can happen. Cool. Yeah, so at this point, I guess I remember the first where a friend showed the power of LD preload. People were complaining about the Braille challenge. Yeah. Okay, so here's my hot take for that challenge. I do agree that guessing challenges are frustrating for CTFs. And the question is, what is just applying typical knowledge versus guessing, right? Is it guessing that tar -c can be used to output to std out? Or is that just knowing the Linux tools kind of well and know that you can abuse it for that way? And with web challenges, is it too much to ask to guess, for example, a robots.txt? Is checking the robots.txt part of everybody's web security arsenal to check that you can assume everybody with experience knows that? Or hiding something in the robots.txt is already guessing because, who would know that you need to access robots.txt? So it's a difficult balance, what is like shared knowledge, kind of that you can build upon, and what is then pure guessing. And so that's why I understand why, yeah, right. And then guessing, nobody likes guessing. If you just have to guess a path or a file name or something similar than that, that's annoying. However, again, if you use certain, guessing can also be more intelligent, right? Maybe you need to guess a file, but that is a standard file for a certain framework. And so by enumeration, you learn what web framework was used, and from that knowledge, you know what kinds of files exist, and then that's how you can find the file. And then it's not really guessing anymore because there's a path. And so it's like very, it's very like what is guessing and what's not guessing is a very fine line and very difficult. And so now the question about the Braille challenge. I think, and we failed with that too, right? It took us a while to find that it takes XML input. But I work in this, I do, web security professionally. I know in production websites, this happens all the time. I see this in source code audits and places and websites all the time, that there are frameworks, or even not frameworks, just like because it's so simple to just register another middleware layer that then handles JSON input, form data input, and XML input, for example. You just add these and then they are there. And so the whole site might only use JSON. Nobody ever uses XML, but it's still in there, and then it can maybe be abused by bypassing some of the filter checks because you can get in some kind of different kind of types, or maybe even XXA or something. So I've seen that in production a lot. So this is not even an obscure thing. So now it's the question, is that still guessing, or because it happens in production all the time, it's kind of to be assumed to be like an industry known kind of thing? And I do tend to agree that it's an industry known thing, and it's not really guessing. However, I feel the challenge was a bit misdirected. I understand like the blind challenge and that input with that weird encoding. I understand the blind was a hint for like blind XSA maybe, but I felt like the challenge was a bit misdirected. That's why we also didn't occur us to check the content type input. We just felt like the challenge was an injection challenge and not an XXA challenge. And so I feel like the communication of the challenge could have maybe be a little bit improved. And this might have been a simple thing. I don't know. They say they tried to hint at it with enterprise ready website or something like this, because enterprises often use like XML endpoints, which I can also agree, okay, so maybe that's 2 steps too far, too many steps for that association. I also wouldn't, it's also not what I would have thought of the first time, but yeah, it's a fine line. I think in the end it was okay. I think in general it's something that you can expect people to check for, but you need to be careful with misdirecting efforts. Does that make sense? And I don't think that this challenge necessarily violated it too hard, because still a lot of people solved it in the end. But yeah, maybe a small little hint that was somewhere hidden somewhere else. Like maybe in the robots.txt you have some traces of some kind of XML endpoint, or I don't know, somewhere a small little hint. But then, yeah, or maybe not, or maybe just, yeah, I don't know what yeah. Yeah, the hint in the description was apparently that it's like enterprise or something. I don't know. I found the flag, but the blind arrow exfiltration was breaking my burp insta for some reason. Huh? What? How? How did that break your... Do you have a weird XML parser in your burp, or why did it break that? It's just text output. A middleware that added X powered by header to leak the middleware use. Yeah, that might have been a good idea. But then again, like if they would just straight up say, I mean, there's a reason why they made the JSON endpoint, right? They could have just done the XML endpoint. But then it would have been so easy, because the solution in the end was really copy and pasting a specific XML vector. It's very easy to figure out that it does some XXA stuff, like it does React, it throws errors, but you have problems with including external DDTs. So it still requires a little bit of more advanced knowledge about this and research to find the trick of using local DTDs. So that's still a little bit of a challenge, but straight away it seems a bit too easy. So I feel like testing for somebody's professional intuition to check endpoints for different types,
maybe the way to go here would have been to extend the web app a little bit, to have more endpoints, and then mix and match and have like one endpoint to use XML. And then you need to realize, wait, these middlewares, like this is all the same endpoints. Every endpoint handles XML and every endpoint handles JSON. So if you have maybe added a bit more functionality to the site and then made one using XML, maybe that would have been a good way, because you still need to realize then that the endpoint then XXA would have worked on the other endpoints too. Yeah, but you get my point, right? Like I feel like there's maybe a little bit more guiding or discovery that you should have been able to do. I don't know, but yeah, I understand the frustration, but I also don't think that this is necessarily a challenge you need to like go really crazy about. Especially, it got kind of a lot solved in the end, right? The point value is fairly low at this point. It doesn't make or break necessarily a place, maybe. Doesn't have that huge of an effect at this point. Copy and paste blog post, get flags from web channels. Yeah, I mean, the Podswigger blog is really good. All right. Okay. Was this the only drama around the Google CTF, the BNV challenge? Or was there more drama that I just haven't heard about yet? Or was people happy? Okay, we have been going on over 3 hours and 20 minutes. Sounds like no additional questions or write-up ideas are coming up. I think we made some really cool progress. We understood today the paste static challenge, which was a hard challenge and no team solved during the CTF, but we were able to understand the solution now. Also, we looked at what was the other challenge we looked at? Oh, the JIT poning challenge with a neat solution. And then we talked a bit casually about some other challenges. That sounds good. So this is kind of like what you should do after CTF. So the CTF is over. You should revisit a bit of the challenges and read some of the write-ups. Not just look over them, but maybe even spend a bit more time, like with the paste static challenge. We spent maybe an hour or maybe a bit more trying to try it out and check out the different, do some experiments about it to understand it. And if you keep doing that, now we learned a lot more about web channels. We learned some new tricks about kind of like how assembly and ponables work. I learned, even thanks to Twitch chat, also a bit more about Kemu and U-boot and bias and that low-level stuff. Just have a bit better idea where to look if I ever face something like this again. So, yeah. Is the code for the little language you made online anywhere? I didn't make a little language. I don't know what you mean. Makes me feel like I'm learning. Well, I'm glad. Awesome. Yeah, I think this is cool. This is kind of fun. I also, obviously, I'm a person. I'm lazy too. I'm not some kind of CTF machine or so, right? I haven't played a lot of CTFs in the past 1 or even 2 years. I want to play a bit, try always to play a bit more. And also, sometimes I'm slacking on looking through the reviews. So being able to use Twitch maybe as a post-CTF meetup where we just have a couple of hours to look at some write-ups maybe together seems like a good opportunity and motivation to work through these write-ups to continuously learn and improve our skills. So that was quite fun. I intend to do this again. I'm not sure what the next CTF will be, but especially because I have so many other things going on. But in the further future, especially after my master thesis is done, this seems like something I would want to do more. That's kind of fun. Yeah. Anyway, the recording of the stream is as always available on Twitch. You can go up in the tabs on videos if you have joined later and you want to see how we have been working through some of these challenges. You can just check out the recording. It will also be made available in a more condensed version on the liveoverflow 2 YouTube channel, where there are highlights uploaded of the Twitch streams. Actually, this post CTF talk, I might even upload this to the main channel just because it is relevant to the main channel. So I consider doing that. Invite a few teams and talk to them on stream over channel. Yeah, that sounds like a cool idea. To get a bit more expertise and get the speed a bit higher up of talking about solutions. That would be kind of cool. I like that. And it's easier than, I presume, convincing them to share write-ups with me. That seems easier. Do you still have some of the recordings of the Django lives? Yes, I do. They are actually, I plan to also upload them to liveoverflow 2 probably at some point. It's just a lot to upload, a lot of gigabytes. Okay, yeah, thanks so much for hanging out with me. Thanks for also playing, I guess, the CTF. Good job. And see you then tomorrow for another, probably tomorrow, probably also again in the later hours, similar like today, hopefully maybe a bit earlier, who knows. No promises, but we will continue building the 8-bit computer, which we have neglected today. Okay, so thanks so much and see you tomorrow. Have a great evening. Bye-bye.